بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we're going to continue talking about numerical sequences, and specifically we will talk about the convergency of a numerical sequence. Let f be a function defined on an interval I. Un is a given sequence with a general term un, and it's defined for all n as a natural number. We say that the limit of un as n tends to plus infinity is capital L if and only if the limit of the function f of x as x tends to plus infinity is capital L, where un is f of n and L is a real number or plus infinity or minus infinity. In other words, to calculate the limit of a sequence un, it's enough to translate the sequence into a function and deal with it as if it were a function. Well, the answer of the limit, as we saw in the limits of functions, could be a real number, it could be plus infinity or minus infinity. We may also write it simply as the limit of f of n as n tends to plus infinity is the same as the limit of un as n tends to plus infinity, which is capital N. Remark, we say that the limit exists when it leads to a unique real number. So, to exist, a limit should be a unique real number. So the limit cannot be plus infinity, cannot be minus infinity, and cannot have more than one answer. Let's see the examples. We need to calculate each limit below, and we need to specify whether the limit exists or not. The limit of 1 over n as n tends to plus infinity, we deal with it as if it were a function. So the limit, if we just substitute, we get 1 over infinity, and 1 over infinity is 0. Now, being a unique real number, we can say that the limit exists. The second one, we need to find this limit. We also deal with it as if it were a function. So in this case of the limit, we have infinity over infinity. We apply the leading term or Hopital's rule, and we get 1. And because 1 is a unique real number, we say that the limit exists. This example, we also substitute, we get positive infinity over negative infinity, which is the limit of n squared over minus n. If we simplify, we get the limit of minus n, which is minus infinity. And in this case, because it's not a real number, we say that the limit does not exist. And finally, we need the limit of negative 1 to the power n. Remember here we have to take two cases when n is even and when n is odd. Now if n is even, we get negative 1 to an even power, which is 1. And if n is odd, we get negative 1 to an odd power, which is negative 1. And in this case, the limit has two answers, which are 1 and negative 1. So it doesn't have a unique answer. That's why we can say that the limit does not exist. Well, let's see application 1. We need also to calculate each limit and to specify whether the limit exists or not. Try to do it alone. Check up your answer. Well, in this case, if we just substitute, we get 3 to the power plus infinity, meaning that 3 is multiplied by itself infinitely many times, and whenever we multiply it by itself, it becomes larger and larger, so the answer is plus infinity. And because the limit is not a unique real number, it does not exist. Part B, try to do it alone. Now in this case, if we substitute, we get 1 over infinity, which is 0, so the limit exists. Part C, try to do it alone, pause the video. Well, to calculate such a limit, we substitute, we get negative infinity over positive infinity. We rationalize the denominator. We get 1 minus n in the numerator and 1 minus n in the denominator. It's the limit of 1 minus the square root of n. By substitution, we get minus infinity, and we can tell that the limit does not exist. Now let's go on talking about property 1, a is a real number. In general, the limit of a to the power n as n tends to plus infinity. By the way, in case of sequences, we always find the limit at plus infinity. We cannot find the limit at minus infinity or at a point, because in this case, n is a rank, and n should tend to plus infinity. So, the limit of a to the power n could be plus infinity, could be 1, and could be 0, and this depends on the value of a. Try to imagine it. If a is a number which is greater than 1 and you multiply it by itself infinitely many times, it's going to become larger and larger, so that its limit is plus infinity. Whereas if a is 1, is exactly 1, 1 if we multiply it by itself infinitely many times, we get 1. And if a is between negative 1 and 1, and we multiply it by itself, whenever we multiply it, it becomes smaller and smaller, so that it tends to 0. Let's calculate each limit, and we also specify whether it exists or not. The limit of 2 over 3 to the power n as n tends to plus infinity. In this case, we see that 2 over 3 is between negative 1 and 1, so the answer of the limit is automatically 0. And the limit exists. Part B, we need the limit of 1.01 to the power n. Well, a in this case is greater than 1, so its limit is going to be plus infinity, and the limit does not exist. Well, part C here, try to divide it into parts. First, radical 3 is greater than 1, and being greater than 1, the limit would be plus infinity, so the limit of this part is plus infinity multiplied by a negative sign becomes negative infinity over a quantity which is about negative 0.7, and the final answer would be plus infinity, which means that the limit does not exist. And finally, we need the limit of this quantity. Remember, negative 0.3 is between negative 1 and 1, and this is to the power n. So this becomes 0, which means that the limit exists. Okay? So far, we should remember that the limit of a to the power n as n tends to plus infinity is plus infinity when a is greater than 1, it's 1 when a is exactly 1, and it's 0 when a is between negative 1 and 1. Calculate each limit and specify whether it exists or not. Try to do it alone, pause the video, and compare your answers. Well, here 2 over 5 is between negative 1 and 1, so its limit is 0, and 5 over 2 is greater than 1, so its limit is plus infinity, and positive infinity multiplied by a minus is negative infinity. Consequently, the limit does not exist. This limit, try to do it alone. Again, a half is between negative 1 and 1, so its limit is 0, and the final answer is 1 over 1 minus half, which is 2. And being a unique real number, we can say that the limit exists. Thank you.